Hi everyone, welcome to our study of acids. Now acids are present in a whole lot of things that you may or may not know about already. We're going to get into the definition of what makes an acid, maybe some industrial uses, how we can identify what they are, but let's start with looking at some of their properties. So acids in general have a sour taste. This does not mean for a second that we want you tasting any chemicals in lab, but it turns out in some of the things you already eat, you may find acids. So for instance, things like lemons have citric acid in them. Lactic acid is contained in yogurt. Vinegar is something called acetic acid, and all of these things we know have a slightly sour taste. Acids will take litmus paper, that's over here on the right-hand side, and turn it to a red color. They'll also react very well with metals. So given that acids, as we talked about when we named them, always have an H plus at the beginning, you can think about your activity series in a single displacement reaction about how hydrogen would react in an acid with different metals and what that might happen, what might happen in those cases. They'll also react with bases to produce salts and water. Now, this doesn't necessarily mean NaCl. A salt in our chemistry world is pretty much any ionic compound, and water we know and love as H2O. Acids are also electrolytes, which we've learned earlier are things that conduct electricity. Why is that? Because when they dissolve in water, they dissociate, they form H plus and some other anion that are able to carry charges, and therefore they are electrolytes. Now, there are two different types of acids that we're going to define, and they're named after the people who define them. So first off, we're going to define an Arrhenius acid. An Arrhenius acid is one that dissolves in water to form hydrogen ions, H plus ions. And you can see down here, if you take H plus and you add it to H2O, you have a third hydrogen and you have a positive charge, you actually get this thing called H3O plus. So for our purposes, the hydronium ion and hydrogen, H plus, are one and the same. It's just with or without water, but both of them are carrying a positive charge. So Arrhenius acid, this is a substance that is producing hydrogen ions when it is dissolved in water. Conversely, a Bronsted-Lowry acid, this is pretty darn similar, but this is something that donates protons, also hydrogen atoms, and this word donate is really important. So a proton donor, again, that proton is H+, is a Bronsted-Lowry definition, but the fact that it is a proton donor makes it a Bronsted-Lowry acid, and this Bronsted-Lowry versus Arrhenius kind of distinction will become more clear when we get on towards bases. Now, there are several different types of acids, and these are distinguished by how many protons the acid contains. So the word mono, or the prefix mono, means one. Monoprotic acids have one hydrogen, for instance, HBr, one hydrogen. HCl, one hydrogen. Diprotic, prefix di here means two, have two hydrogens. So for instance, H2SO4, H2CO3. And then polyprotic have more than two. So for instance, H3PO4. Phosphoric acid has three hydrogens. We'd call that polyprotic or even triprotic in this case if it has three different hydrogens. Finally, for today, there are a bunch of strong acids that we need to be aware of. So these seven, HCl, HBr, HI, HNO3, HClO3, HClO4, those are all strong acids, and we're going to throw sulfuric acid, H2SO4, in the list. That's the only one that is a diprotic acid, the only strong diprotic acid. You'll notice all of the other ones are monoprotic. So this is really important because strong acids, when they are dumped in water, they dissociate completely, which means, for instance, HCl splits completely into H plus 1 and Cl minus 1. And that happens completely 100% dissociation. It turns out that all other acids, anything else that you can think of that starts with an H, they are what we would call weak acids. And weak acids do not do this. Yes, they split into H plus their anion, but it's not complete. And so the math for them is a little bit more complicated. They use something called this equilibrium constant.